Hi folks, I'm Michael Wybrow and this is going to be a replacement for what would be the week 1 workshop. This semester we have lab classes that are on Monday through Friday, and as a result we can't have our workshop before the lab classes each week. We typically like the workshop to be before the lab classes so that we can go through various things that occur in the lab classes. We can show the lab exercise. So this is going to be a sort of informal video. I'll try not to make it too long. It's going to be kind of informal. I'm just recording this at home on Saturday because we had some problem with the lab computers at the end of last week, so I didn't get a chance to do it then. Apologies if you hear the sound of my dogs in the background, but we'll just work through that. So let me just talk to you about what we're going to do in this video. First off, usually in the week 1 workshop, I would spend some time talking about myself, why I'm teaching the class, a bit on the philosophy of the class, but let's do that in person as part of the week 2 workshop. But because you'll have started classes and started work, I just want to spend a minute or so talking about help. In terms of getting help, workshops are a great place to get help. You can ask anything at all in the workshops. You can ask me about lab questions. You can ask me about things related to your assignments. You can ask us about anything else, really, even things that are not covered directly by the workshop material, but are just in the area of iOS or Android development and that you're interested in. That's fine. Obviously, if you watch the pre-workshop videos each week, you can, you might have questions based on that, so feel free to ask those questions in the workshop. For lab classes, sometimes your demonstrator will be busy helping other people or marking you if we're talking about the interviews in later weeks. So, you can get the best use out of your lab time by starting lab exercises yourself, finding a problem, and then asking them questions about it. As the semester goes on, I should say, you're welcome to drop into other lab classes if there's space, but the demonstrators will prioritize the students in those classes. Ed forums will be responsive in there. We'll also hold consultations where you can bring along a problem. Some of those consultations will be in MacLab, so if you don't have a Mac, you can still show us your problem with your assignment on the computer in front of you. And then we have a unit email address. Please use this rather than emailing Jason or myself or even your other TAs directly. Your lab demonstrators are not paid to answer email queries and things outside of class. So you shouldn't expect them to reply on a weekend or something like that. If you have problems, contact us via one of these methods. Each week in the workshop, I'll talk about what the learning outcomes are for that week, which is what we'd expect you to know once you've done all of the activities, as in you've watched the pre-workshop videos, you've been to the workshop, and you've done your lab exercises. Okay, so for this week, week 1, part of it is about understanding the unit structure and assessment, as you would have seen from the first couple of pre-workshop videos. We also want you to be able to describe at a high level iOS mobile architecture, which is what the 4th video, I think, of this week was. And we want you to be able to implement simple programs using Swift inside an Xcode playground. And that's really what videos 5 and 6 of the pre-workshop activities were like. They suggested you try some of this code in Xcode playgrounds. Hopefully you've had a go at that. And then we want you to construct or be able to construct a simple single view iOS app using Xcode. And that's really what the lab exercise this week is all about. The next thing I'll usually do in a workshop is I will demonstrate what the lab exercise should look like when you're finished. So you obviously have the lab instructions, which will walk you through what you need to do. And these are guided exercises, and that will be the main part of the lab exercise. But you might also find it useful to see what the app should look like with the extension activities, which are optional, but they're assessed. And many students like to either complete these or at least attempt them. So in each week's workshop, we'll show you what the final version of the app would look like. We won't show you the code, obviously, because that's what we want you to get you to do as part of the activity, but we'll show you the result. So why don't we do that now? So to do that, I'm going to bring up a copy here of the lab exercise for this week. And this is a completed one. This is the simulator that we will mostly work in this unit. I can make this a bit bigger too. Let's maybe do it like this. So you can see it well if you're on a smaller screen. All right. And the simulator is really like a working version of iOS. It's got different apps, like a Photos app, which won't have any photos in it, but you can, actually it does have some photos in it that we might have put in the past, but you can see it behaves like the normal app. It requests access for things like notifications. You can tap on a photo, interact with it. We can go back to the home screen, which you can also do by this button here or via the different shortcuts. We could do something like the Maps app. Settings app, so you can control various things like accessibility features, which we'll look at later in the unit. So this is where we'll build and run our apps. And there's different simulators for different devices. We look at this a little bit in the week 1 lab. So the guided part of the week 1 lab will look like this. It's a simple kind of Hello World app in Xcode with my project open and a particular simulator selected. I just click the play button and it'll build and run, and we'll see the app here. If we go back to the home screen, you'll see this app has now been installed and it's there. So we can run it again. This app basically has a couple of text fields. When you click on them, because it's a simulator, it uses the keyboard of, in this case, my MacBook Pro. But if you want to see the normal keyboard on the screen, there are some options where we can toggle this, and the keyboard shortcut for the IO one is Apple K, which we can also find as a menu option here, toggle software keyboard. So if I do the keyboard shortcut for this, you'll see the standard keyboard come up, and you can interact with it by tapping on it with your mouse cursor in this case, or we can just type on my keyboard. So I could say, Siri, what's your age, and say 13. And it'll show here what's called an alert view controller that has a single button to dismiss it. So that's basically what the app does, and you're writing the code to take the values out of these text fields, display them, and present that alert view controller. We also do the work of using constraints to determine layout for these. So, for example, if I tilt the device, these UI elements lay out, and you'll see, because here's the dynamic island, which is where on devices like the iPhone 16 Pro, the camera for the FaceTime unlocking and things like that are in here. So content needs to fit around it. So there are margins on both sides to make sure your content doesn't go under this, unless it's like, say, a photo in the Photos app where we would expect it to, and it's okay to go under there, or a widescreen movie maybe is okay for it to go under there too. Okay, so that's what the app looks like in its basic form. Let's have a look after what it looks like after extension 1. So I'm just going to switch the code here to be a version from when I'd committed extension 1. So extension 1, rather than having an age, you enter a birth date, and you enter a birth date with a particular format, and using that date format, it's going to then present that date format just in a readable, human readable form. So I can say, Jenny, and give some date here. So like 2004. Let's do 07, 13, something like that. And we say hello. And basically what it's doing here is it's taking the date and it's formatting in a nice human readable form. So you're making a couple of changes. You're changing the label here. We're changing the name of this text field. We're changing the text field so that it validates a correct date and will show an error if it doesn't have a valid date. Right? And then assuming it works to still display the field. You'll also notice it asks you to put a placeholder in here. So what happens with a placeholder is if a text field is empty, then you see that text instead. So that's what extension 1 looks like. And with each of the extensions, there's a requirement that you do a little bit of research and read documentation, and we point you to the appropriate classes. If you get stuck, have questions about that, you can also ask on Ed or somewhere like that, or in consultations. So this is what extension 2 looks like. We still have the birth date, so let's, you can tell I'm using a made-up character because I won't be able to remember what actual date I used. Was it 2004? Maybe it was 7, 13? Maybe I am right. We click say hello, and it now says, hello Jenny, you're 21 years old. So what it's done here is it's taken the birth date and subtracted it from today's date. And the simulator knows the date, in this case Saturday the 26th, and it's using that as the current date, and then it's telling you the number of years old you are. So that's what extension 2 is. Now the final part is extension 3, and with extension 3 you're going to use what's called a UI date picker, which is a UI control. So basically all we've done is disconnect these elements, and instead when we say hello, we're taking the date from this component. And this component is the date picker. What happens when you tap on it, you can select a date, and I can just click on a particular value and you see the date field change. I can skip back and forth through months. If I also want to select, say 2004, I'm not going to click back through 12 times a year for 20 years. No thanks. I can also tap on this element and it gives me a spinner where I can scroll back. There's a little click sound you hear here. I don't think I've set up my screen recording to capture that sound, so I don't think you'll hear it. But we can select one of these. I think I'd said July, and then you'll get the days for July, and then when we're done here we can click say hello. Oh, we do need to enter a name, and when we say hello we get the you are 21 years old. Now it's worth noting that in our storyboard, that's interesting, didn't display for a minute. Here's the date picker with its preferred style, which is the automatic one here. But we could also change it to say Wheels, which is an older style date picker that used to exist a few years ago. and you'd get something like this. So there are a few different versions of the date picker that are available, and you can use whatever's appropriate for your app. So that's what the lab exercise would look like. You know, if I was doing this in the workshops, you'd be able to ask questions about this as we went through. But here it's really just a demonstration, so you've seen this ahead of the lab class. Now I'm going to talk about a couple of things I would usually discuss about Swift and some of the questions that students would typically ask in the first lab, in the first workshop. And then what I'll do next is I will do a bit of live coding with a basic app, just a single screen app, a bit like what is done in the lab exercise, just to show you some common problems that you might encounter. So let's maybe look at what I would typically ask as a couple of interactive questions. One of the things we would usually have as a bit of a class discussion is this one, which is about what things are unusual about this if you consider it from a Swift perspective. So our Swift introductory materials would have told you a few things about Swift, and you should probably look at this and go, oh, okay, something is wrong with that from a Swift programmer's perspective. So we'd usually do this as a class discussion, go around and have people make suggestions. And what I like to do here is actually show this in a Swift playground. So you can see that we get the same result. Our code is completely equivalent. This is code that works in Swift, by the way, but it's not the most efficient way to write it. So perhaps the best way to do this is if I just open a playground and we can paste this code in and have a look. So let's do that. To create a new playground, we can just say new playground. When you create a playground, and this window's gone onto my other screen, but let's see if we can bring it across here. Okay, so we create a blank playground. I'll just stop this iOS simulator. Okay, so let's call this workshop 1, playground. We get, this is an Xcode window. It just has a lot of things hidden. So there's kind of controls that you can quickly hide and show some of the parts of the Xcode window, like the file explorer or like the different inspectors on the right-hand side. So this is where I sort of show some other things that aren't in the lab exercise for the week, but we can just leave these collapsed. When we run this, we would get the result. So you'll see it will compile and run, and it will be pretty quick. It says launching, running, and you see some results over here from each line that is run. Let me see if I can expand this. Ooh, there we go. All right. So let's let me just find a copy of this code, and we will paste it in here. Excuse me. So if we run this, we get some results here. It sort of evaluates each line, and you can see results from this. Now what we don't see is what we would expect to, 3 lines of output. Excuse me for a second. What we don't see is 3 lines of output, pug, blue heel, or Dalmatian. And that's because it's displayed to what's called the console, and the console isn't visible. But if we click this little button at the bottom, we'll get some lines displayed, and this is the console right here. And if we were to run it again, you'll see those 3 lines displayed. So let's have a look at this. What's some of the things that you might notice? First thing is semicolons. They're not needed in Swift. So we can get rid of them. Basically, each of these lines, not needed. And if we run this, we see it's perfectly happy. It gives the same result. So don't use semicolons. Don't worry, you'll still see me use semicolons. I learnt a lot of C and C++, and I have the use of semicolons very trained into my muscle memory. So sometimes I write a line of code, even though Swift is absolutely my preferred programming language. For those of you that know many languages, you probably have some languages that are your comfort language that you would quickly use to write a piece of code if you needed to, and you'd have other languages where you'd have to go and check syntax and look up things and you wouldn't be sure how to do everything. Swift is now one of those comfort languages, but I still occasionally put a semicolon in. The next thing is probably that you notice that type descriptions are not needed. In this case, they can be inferred. It knows from this assignment that dogs is an array with strings because this is the array literal, square brackets, and the things inside are string literals because of the quotation marks. So this is not needed. Obviously you could put something else in here, and if we try and run this, you'll hear about it. It'll say cannot convert value of type string to type int. So this is where the Swift compiler infers types, but it's strictly typed. Swift is a strictly typed language. So if it can't figure something out and it needs the declaration because you're, say, initializing dogs with an empty array and it doesn't know what the type of things in the array are, it'll ask you. In fact, we could show that, couldn't we? Could we? Because printing, yeah. Why not? Why don't we do that? So this is the kind of thing we do in live coding where people ask questions in the class. We can sort of mess around and try different things. So here you go. This is the kind of error it'll give. Empty collection literal requires an explicit type. But then if we have the type declaration, then it'll be happy to run this code because it now knows the type of that thing, and then it can check that it can print a string. So you can see how this works. Let's go back to where we were with the our working code. All right, so we don't need type declarations. What else? This looks pretty good. Well, we don't, and we typically wouldn't and don't need brackets around expressions, whereas in like a language like C, they're a requirement. They're part of the syntax of an if statement. You can still use them because if you want to have compound conditionals, then and you want to express precedence between different things, you can certainly do so. So we can use brackets and use ampersands and and or all that kind of stuff. That's fine, but not necessary here. What else? Well, the dogs array is never modified. So, if we're making changes to it, it needs to be var, but if it's never changed, it can be a let variable. So usually we would say this is let. Obviously, index can't be a let because we mutate it. So if I try and make index a let variable, what happens? It says left side of mutating operating isn't mutable because it's a let constant. And, it'll suggest fixes a lot of the time for this. So here's the Band-Aid fix. Change let to var to make it mutable. Oh yeah, that's what I meant. Let it fix it, it'll fix it. So the Swift compiler its error checking and warnings and errors are very good. They won't always understand your problem, but a lot of the time they will do the right thing. So you can use them. There's one final thing that is maybe a bit weird here. While we can certainly write while loops, this is maybe not the most simple and succinct way that we would write this code to iterate over an array in Swift. And instead what we would do is probably write it like this, for, and we would say let dog in dogs. And that basically says we're creating a variable that's used on each iteration of the loop, and the thing it's looping over is dogs. And then we want to print the dog. So we would say print dog. And yeah. See what it suggests. Okay, it doesn't suggest anything. We can just say for dog in. I don't even need the let. If I get rid of this and run it, you just get exactly the same thing, right? So this is probably the version you would expect to see written in Swift code. Let's look at another example now, and this one touches on something particular that can be an issue that you may run into in the first couple of lab classes. So it's something we want to point out to you and show as an example. And that's particularly how, okay, here's an example where I pasted some code. Notice that things are messed up in the indentation. So there's a keyboard shortcut for this. I know the keyboard shortcut, but if you don't know it, but you want to look up how to fix indentation, in any Mac app, from the help menu, you can search. And when you search, it will search all of the different menu options, and then it will show you where the menu option is. So if I just do indentation, you can see here there's a menu item called structure reindent, and it's under the editor menu, and it's halfway down under this structure and reindent, and it's actually Control I. So if I do Control I can indent, auto indent everything that's there. If I want to shift a block of code left or right, I can do Apple and square brackets, open or close square brackets. So let's just try those two things. We can obviously click on this and it will reindent it. Or if I click undo and just do Control I, it'll reindent it. If I really wanted to, take some code and indent it or not, I could take these lines, and do Command and square bracket in either way. So these are some useful things. Okay. So the question here is, what will this code print? So just look at it for a second if you weren't reading it. We've got a structure here with a couple of properties, a string. We're creating an array that's 3 instances of this dog object, each a pug, a blue heeler, a Dalmatian, and some ages. We're taking the dog at index 1, which is the second index, because arrays are 0 indexed in Swift, as in many other languages. We're setting the age of that dog to 1, which should be the blue heeler here. And then we're printing this out. So there's a couple of things we could expect it to print. If we weren't sure about this 0 index thing, we could imagine it might print pug 1, blue heeler 2, Dalmatian 3. So 1, 2, 3, 1, 2, 5, sorry. If we knew the index was right, we expect it to be operating on this. And we might expect it to print 12, 1, 5, which is a very common answer I see from students. Or if you're particularly keen-sighted, you might expect that it prints 12, 2, 5. And in fact, that is what happens. Get 12, 2, 5. Now, if that wasn't what you expected, you may be asking yourself, why? Why does this happen? And the reason it happens is the way that copy by value and copy by reference are different for classes versus objects. So because this is a structure, it's an object, as opposed to if I change this to be a class, then it would be a class. And these objects and classes have different behaviors when it comes to copying them. We're creating a copy at the point we do this. We say Bluey equals the element of the thing. So because this is an object, we make a copy of Bluey, we change the age of that dog object, but it's changing the age of the copy, not the one in the original array. And we prove that to ourselves because we see that 1 isn't shown here. We could do some things differently if instead we refer to that object directly here. We see 1215, so it has changed the age of it because we've directly referred to it instead of making a copy and changing that copy and having that object, that value be lost. So this is something to be aware of when you're using structures. And I can show you how it behaves differently for a class. If we were to change this struct to a class, now, first off, a class needs to have an initializer. So I don't know if its fix will be to create a, oh no, its fix is to initialize it. So let's, rather than doing that, we can just create an initializer. And the initializer that's suggested for us should be fine, right? It's got breed, age, which is the right order we have here, and it says self breed, which is how I refer to itself. This is basically what we give as an example in the pre-workshop video as how to write classes. So that's fine. Our code now is good, and if we run it, we see the value is changed, even if we use this approach where we make a copy, because we're copying by reference. So the version in my local variable Bluey here is actually this dog, and when we make a change to it, we change the value. So yeah, this is a place where, if there are further questions people have about this, we might explore it further. Obviously, you can't do that in this video, but if you don't understand this or you want to ask more questions, ask on the Ed forums or play around with it yourself. I would say if you want to understand how Swift code works, the absolute best way you can do that is just try things out and test them. Often if people ask questions in workshops, even if I know the answer, I'll often demonstrate it live together, because that's what I want you to be doing. When you have these questions, try it out, figure out how it works, what it's doing. And in fact, our lab exercises for the date classes, the date formatter classes that we suggest in the extension activities, we suggest you try those classes out, initialize an instance of it, use it in the Swift playgrounds, and just do exactly what I'm doing now and get a sense of how they work. And that's a lot quicker than building the app each time and entering some values in a text field. You can very quickly just try out some code here and check that it works. So we do a couple of activities like that. Oh yeah, I could show one more of these. Actually, I'll do one other thing with this one. Yeah, okay, so there are also a number of useful array methods in Swift. So, yeah, maybe I'll just bring up the documentation. So here's the developer documentation under the window menu. Here it is. Let's say we just search for array. And I don't know if this is built, so apologies if this takes a moment. Yeah, okay, it's quick. Here's the array in Swift. It's a collection, and you can see lots of things about accessing arrays, modifying copies arrays, and then a whole bunch of array methods where you can do different things, like appending, inserting. So this is adding elements, combining arrays, removing, finding elements, selecting elements, iterating over, sorting an array. So this is where, like, even we've got a simple activity with an array, you could play around and understand how you could use a number of these. So one of them is maybe something like filter. So like, let's say you wanted to have the dogs that were puppies. You might say something like, let puppies equal dogs dot, and you could say filter. And oh, this is nice. When we filter, you need to give it a closure, and with that closure, that closure needs to be able to be passed an element, that closure would get called. Closure is just a block of code, as we said in the pre-workshop videos, and it would get called for each element of the array. So in this case, are 3 elements. And in this case, what we would want to do is check the .age property, and if it's less than 2. I don't know if it is a puppy that's equal to 2 years old. This is Swift's code completion, which uses an AI model, and sometimes it will do the right thing. It won't always do a perfect thing, but it's pretty good. If we just let it complete, we'll get this piece of code, and it's interesting. I didn't get, I can expand this anyway. This is the longer version of the same filter. So I can just give a property name, dog, and then we can say exactly like it suggested, dog.age is less than 2. I might have hit enter or tab by mistake. I don't know what I hit, so it didn't complete into what it had suggested. But this is exactly equivalent to what it had suggested before. And if we run this, we can find, we get an array of 1, and I could check this because I could then print out the puppies. Let me just grab this code and oops. So let's see. Which puppy did it? Okay, so it got the blue heeler that's 2, and if we make one of these 1, then presumably it'll get both of them for us. Okay, so we can see that working. And yeah, that other version was just a shorthand of the closure syntax. Okay, cool. So I think what I'd like to do now, just to finish up, is show a quick new project, and let's see if we can just encounter a couple of things that you might see in the lab exercise that should help you out there. Okay, so let me create a new project. So new project, oops. Interesting. Why does it have project grayed out? I have no idea. Just give me a second. Maybe it has an open new project window somewhere. New project, I don't know, something weird there. Okay, so we're going to create an iOS project, and this is pretty much mirroring what we do in the lab exercise this week. I'm going to call this Workshop 1 example. It's going to be a Swift storyboard app we're not going to use testing or storage, so I'll create it now. It can just be in my test directory here. Here's my project. I should be able to run it. It'll be empty, it'll just be a blank screen, but it'll be a working iOS app. Sorry, it's connected to my physical phone, but I need it to be connected to this simulator we have here. Okay, let's try again. So we'll build it, run it, and here it is. So I thought I would create a very simple kind of color picker app. So at the moment we have a storyboard here. This is Interface Designer. I'm going to open our picker here. One thing that can be useful if you're doing a few things at once is often you can hold down the Alt key when you do something like launch this window. With this window, if I say create a slider and drag it onto here, that window disappears and I've got to launch it again and search and whatever. If you hold down Alt when you click on this one, sorry, didn't mean to do that. If I hold down Alt when I click on this, I get it as a standard window with little window controls, and it'll stay around, which means I can, drag a couple of things here and it's all good. So I've got these sliders. I think what I'll do is let's put these sliders down here, and I'm going to also create just a view. So we'll just look for view. So here's our view. Okay, so I'm going to use this for my color preview, and I'm going to use these three sliders to control it. And we're going to control the color components of this, a red, green, and a blue color component. So, we're going to, well, actually, let me just run this and show you this now. Let me actually add a color to this one because I want you to be able to see it, because white on white is not going to be visible. So if I find this view and just set its background color to, I don't know, system pink. All right, and we run this. So this is, in the lab exercise, we're not really doing this. If I rotate this, things are kind of all right, but not great. You notice that this thing underlaps the dynamic island. These things are fixed width. This one doesn't go over to the side of the screen. So let's do some improvements of using constraints. So, and it's worth noting, some things actually don't show up properly in Interface Builder until they're constrained. Like I think the date widget in the extension activity, when you use it, you might find it displays weirdly, and then as soon as you constrain it, it's happy about its size and it'll display properly. So just be aware of that. Okay, so I'm going to set up the constraints on this. So we're going to go here, and I'm going to set up this to be, say, 32 from the top, 16 from each side, and I'm going to also give it a fixed height. In this case, maybe 100. So I add these constraints. This thing is going to be displayed here. I'm going to set up the constraints on the next one. we'll do 32 and 16 and 16. We don't need to give a height to the sliders, they get an automatic height. I'll do the same for the next one and say 16, 16, 16. And I'll do the final one here. Let's say I get one of these wrong. Maybe let's just put in I don't know, 45, and actually let's do this one as 284 and 16. Now, when you've done this, you might look at it and go, okay, this is not right. That's not what I meant. Something's gone wrong. So how do you fix this? Well, we can click on any element here in our interface builder and you have a visual representation of the constraint. If you click on any of these constraints, it will show in the inspector, and you can see the individual constraint. You can see the items it applies to. You can switch these. You can, if it's something to a top of something and it's meant to be to the bottom, you can correct these. You can also delete the individual ones. So if you want to select one of these and just delete it and recreate it, they're also listed here in the view of the constraints. So you can also step through them one by one if there's one you can't physically find. And we can see each of them here. So we can find the one that's the problem, like maybe this one, and we've realized, this one shouldn't have been 45, it should have been 16. So we can change the value here, hit enter, and it will correct it. Likewise, we maybe didn't intend this one to be 248. We can constrain this one differently to be 16. There's also a number of different ways that you can set these up. Like we could constrain the first slider here and not bother setting the right hand side of this one, but instead just constrain these three to be the same width. And how we would do that is with an alignment constraint. So, I could actually just show you this. I could delete this one, I could delete this one, and instead I could select these three elements and I could say right align these by their trailing edges and add a constraint, and you get them like that. Or even I could hit undo here. And I could set it with an offset as well. And you'd see something different. So you can play around with these constraints and understand how they work. Have I got those three? Yes. So I can do trailing edges. So yeah, actually you don't see them because they're basically going like this here. Should have done them as -16, you'd see them this way. Anyway, let's do them as I think they're equal now. So let's have a look. We can run this. So here are sliders. Oh, there you go. You can see the offset by 16 because they're basically right to the edge of where the safe area, which is the displayable region minus the margins, is called. If I resize this, you can see them adjusting. That one's padded by 16. It's here. These go to the edge of the screen. So we can go in and fix that. We would just select this alignment, which is the safe area. No, it's I can select this as 0. And then there's one more, I guess. Is it this one? No. No. Yeah, I think it's all good now. Let's have a look. Oh, no, still one that's wrong. This is where I'm going to check. It should be not that one, not that one. Yeah, it's this one. So this is the horizontal alignment by the leading side of this slider and the safe area. No, that's not the right one because that's this one here. My apologies. So this one, this one, this one, this one, this one, this one. This one is a horizontal trailing constraint between two. Yeah, okay, so this is the one that's incorrect. See, it's basically the trailing alignment between these two items, and it's got 16. So yeah, this was a good example of me going through and debugging some constraints that are not quite right. If I fix this, I should now have them all three aligned. Okay, so also, like in the lab exercise, we should be able to take this view controller and tell it to be embedded in a navigation controller. And now we've got a navigation controller and this sitting inside it. And when we do, oh, interesting. This is a good one as well. Let's have a look at the top constraint here. It's the top of this view is constrained to the super view. We don't actually want it to be constrained to the super view. We want it to be constrained to the safe area. So it obeys the fact that it's in a navigation controller. And even then, even if it wasn't, it would obey the dynamic island and move down. So now I've fixed that. You'll see it's changed to a constant of 130. Instead of that 130, I'm going to change it to be I think I want these switched around. Safe area 130, and we want just like 30. What do we say? 32. Yeah, okay. I'm going to switch this. Okay, here you go. So now we get something where you'd have the title here and then it's 32 points below. Okay, great. So we've got something that is now our right size. And just to finish up, I'm going to connect some code to this. So this view controller is represented by this code here in this view controller class. This is the controller for that view. If we go back in here and go here and say assistant, we're going to end up with the code side by side. And what I can do now is I can create some outlets to represent these elements in code. So the first one I want here, and I can just drag it across by control clicking. I select the element in the view, I drag it into here, and you can only drag it into the class. You can't drag it outside of, because it knows this class is connected to this view controller. And we create an outlet, and that's a way we refer to it. And we say something like red slider. So there's my red slider. I'm going to create my green slider, red, green, blue. So here, and we say, yeah, here's my green slider, and I'm going to say blue slider. Okay. And finally, I want to be able to use this color preview thing. So I'm also going to create an outlet for that. And I'm going to call it color preview view. So here's my color preview view. It's a UI view. Okay, so got these. Like we said in the lab exercises, see we've got connections, these little filled dots here. And you can tell which of these things connects to what thing. Now, what am I going to do here? So I was wanted to make a change to, well, actually, no, I'm going to, let's make it so we can interact with the sliders and change the color. The easiest way to do this is we create an event for when one of these things changes. And how we would do that is with an action. So we can drag it in here and say an action, and it says, you know, if it had said outlet, we could also change it to action here. This is a value changed event. So if the value of the slider changes, this piece of code, this action method, will get called. So let's call this slider value changed. So here's my method. This is going to get called whenever something changes. So I'm going to what am I going to do? I'm going to do a little check here and say if so we can see here the sender is any. This basically is an action method that gets called by any piece of code. In this case, we know it's going to be called by this particular slider. So we can actually change the type of this sender to be a UI slider, and that's still type safe. You then couldn't connect this method to a view, for example, because it wouldn't be the correct type. But given it's a slider, we know the sender that sent this event is this. So we could say something like if sender is equal to the red slider, then we're going to print red, right? And if we do this, we can run this code now, and we should see in our console down here that when we drag the value, we see red printed a bunch of times, right? So that's working. Interestingly, if we were to change this to green slider, or maybe blue slider, and change it to blue, and I'll make this code available on Moodle if you want to try it yourself and come back and do some of the things I'm doing. If we drag the red, green, blue slider, we don't see anything. And we don't see anything because this method is not even being called. We can put a breakpoint here, and if I drag the slider, nothing happens. If I move the slider here, we hit a breakpoint. It knows that we've hit this piece of code. And we'll talk much more about breakpoints in future weeks, so don't worry too much about the debugging part for the moment. I'm just going to go back to the storyboard here. So we can have a little thing here that points, that says like either red, green, blue, for if the red or the green or the blue value changed. So, I mean, what would this look like? We could just go into this view controller for a minute and say if the sender is equal to red slider, say red. If the slider is equal to the green slider, we say green. And if the slider else if sender is blue slider, then print blue. Okay. Now, we want to actually make a change here. And Effectively what we want to do is we want to create a color. So we're going to get the values of each slider. So I'm going to say, not int, var, or in this case it can be let. And we say red value is equal to, oh there you go, suggest for me, CG float from the red slider's value. So that's true, I want a floating point value. So I can, oops, I can just hit tab and it will complete it. I'm going to say let green value and take that slider value, and blue value and take this one. And look at this, it's even suggesting what I would likely want to do, which is set my color preview views background color to be equal to red value, green value, and blue value. In this case, an alpha value set to 1, so it's opaque. So we'll do this. This is correct. This is in fact what I wanted. UI color is the class that I need to give to the background color property. It's the same one I set in the attributes inspector when I made this pink. But this is just doing the same thing in code. Because we've created an outlet, we can refer to the properties of that view and change it. So I'm going to run this code, and I should be able to drag the red slider, the green slider, and the blue slider. I should be able to drag the first one at least. So if I drag it, I see different values from the red component. If I drag this one, nothing happens. If I drag this one, nothing happens. Now this is the point where I'd be asking you folks in a workshop, why does this not work? And the reason it doesn't work is because this method, the action method, is hooked up to one slider, this slider here, but it's not hooked up to the others. And we can totally set up this action to be called on the other ones as well. And how you'll do this isn't in the lab class, but this is something else useful. We could drag the other sliders, and instead of dragging them to an empty place to create an action, we can drag them to an existing action. And as long as they're the same type, this will work. So I didn't actually do it there, but that's one. And I can do this one too. And if I do this now and run it, we'll have a piece of code or an app that I can drag the red value. I can drag the green value, and I can drag the blue value. Okay, so this is all working, and this is really nice for us. If we wanted to see these connections, if you click on an element here, and this is where you're getting much more from the workshop than you are from the lab exercise, because we don't go into this detail, but there's a connections inspector. Here you can see the red slider is referenced by an outlet. You can see the value changed, and here are a bunch of other events that can happen, like touches inside, its editing state being changed, calls this slider value changed. Okay, so, and if you were to have a look at one of the other ones, you can see that they also do the same thing. Now finally, those of you might have noticed I put green here, and Gren instead of green. So I'm going to fix this. Okay, so we fix this, and I'm going to run this. I get some errors. So what are my errors? Cannot find Gren slider in scope, so yeah, we need to fix this. It should be green, and this error here should be green. So we fix those. Let's compile and run this. Whoa. Okay, so this crashes, and in fact it tells you here undefined key, this class is not key value coding compliant. This is a really, and you can see it still refers to this previously named Gren slider, even though we've changed the references to it. So what's going on here? This is where the connections between our storyboard and our code can get disconnected. And they can get disconnected if I rename something like this. And the way to debug this is to go to the view controller and together look at all of the connections at once. And you'll see a list here. And in the list, I can maybe zoom in on this a little bit for you. You can see here there's one that says this view controller does not have an outlet named GrenSlider. So, I mean, you can undo things and put back the name as it was, and sometimes you can fix it that way, but you can also get stuck. So I want you to understand that you can select the view controller, you can come in here to the connections inspector, and you can look through and find the one. And if you do it for the view controller, you'll get it at a top level for all of the outlets in it. Whereas if you just select one of the particular things, you'll only see it, and it can be harder to find the problem. So in this case, we can remove the broken outlet, and that will fix our crash, but you'll notice that this is not connected to anything anymore. So I can drag my, well, because we try and use it to get the value of one of the sliders, this is not, I've gone off script, but we found another bug, so we'll figure out this one. This says unexpectedly found nil while unwrapping an optional value on line 35. And this was for the, well, actually, let me show you how to find the problem here. If we, for this fatal error, if I set a Swift error breakpoint, will this catch? No. Okay, this can be tricky. So what's basically happening here, we talked about Swift and optionals. And I said, you know, with optionals, I never want to see exclamation marks in your code. You'll notice places that Xcode does it for you with things like outlets. It guarantees that there is a thing called slider, called GrenSlider. Now, when this gets used, it runs into the issue where it tries to unwrap an optional that's actually nil and it crashes. Does it do it with the exception too? I'm just going to check if we can catch exactly where it's happening. UIKit thread serial. No, all right, leave that with me. That's tricky to find. Anyway, but we can, let me just turn off these. All right. We can fix this by reconnecting this GrenSlider, red, green, blue. And I can do that the opposite way to how we saw before, dragging from this circle onto the slider and running this. And when we do, we now have something that works. Also, if you want a safe way to do this kind of renaming, how you can do that is, let's say we've got something like this color preview view, and we're like, oh, that's a horrible name. We don't want to call this color preview view. We'll call it selected color view or color select view. Then you can right click on it and say refactor and rename. And when you rename it, Xcode is clever enough to go, oh, okay, it's used here, it's used here, where we're setting the value of it, and it's used here in the storyboard for this outlet. So if I then rename it and call it color select view, it'll change in all places. And you can optionally select documentation, and for each of them you can actually click on them, this or the tick, and say, no, I don't want to change that one, or I do. And if you change it here this way, it won't break any connections. You know, I can run it now and everything is a-okay. Okay, so thanks for watching this video. This is hopefully showed you some of the common kind of problems that you can run into. This code will be available on Moodle along with this video, so if you want to download this project and just have a look at it and you know, try some of the things I did in terms of fixing the connections between the outlets and the actions, then that's yeah, something you can practice on. All right, thanks for watching, and I look forward to seeing all of you in person for our workshops starting this coming week. See ya.